Hi, welcome to lecture series on network analysis. And in my last lectures, I had explained about the concept of source transformation, and also we had discussed about the problems on for source transformation. Now, if in a problem, if we are not able to apply source transformation directly, or we are not able to convert a current source to voltage source or voltage source to current source, then we should apply source shifting. After applying source shifting, we can able to convert the problem into a source transformation. So what's the concept of source shifting? See, the concept of source shifting, let's take for example, in a scenario, there is a voltage source and there is no resistance. It is directly in series with the voltage source. See, in this scenario, the voltage source V can be pushed towards the node A such that I can apply voltage to current source transformation. So we have converted through the process of source shifting. I have pushed this voltage source towards the node A such that now we will be having an internal resistance which is associated with respect to the voltage source V. So you can apply source transformation. And in another scenario, so this is the voltage source V. This is the another scenario where four resistances R1, R2, R3, R4, which are connected like this. Now, the voltage source V, there is no resistance which is directly in series with the voltage source T to apply the source transformation. So what I can do, I can push this voltage source V towards node A such that R3, R4. Now I have pushed the voltage source V towards node A. Okay. This is the one scenario of applying the source shifting. In or otherwise, you can pull that voltage source towards the node B, towards the node B. So this is the case. So I have pulled this voltage source towards node B. So in both the cases, I have just I'm able to apply the source transformation. So after applying the source shifting, that is the voltage source shifting. Now let's see how to apply current source shifting. So in the current source shifting, let's take a scenario where there is no resistance which is directly in parallel with the current source. So I'll take this scenario. So R1, R2, R3. So now we can witness in this particular problem, you cannot apply current transformation directly, current to voltage transformation directly. So what can be done? See, this current is traveling from node C to node A. So I can make this current source to travel from node C to node B first, then from node B to node A. So it is not changing its path. So in order to convert this problem where we can apply the source transformation, so I can go with current shifting. So now I'll move this current source from node C to node B, and again from node B to node A. Now we are able to witness that there is a current source and resistances R1 and R2, they are directly in parallel. Now you can convert this current source into equivalent voltage source. Okay, let's discuss problems on this. Let's discuss one problem. So now in this particular problem, we should find the voltage across the nodes A and B. See, in this problem, you can clearly see there is 5 amps, which is if I designate this as node A and designate this as node B, sorry, node C and node D. If the current is traveling from between node C and node D, so and there is no resistance which is directly in parallel with this 5 amps. So what I'll do, I'll apply current source shifting. Okay, I'll move this 5 amps from node C to node A and then from node A to node D. Okay, node A to node D. So now after applying the current source shifting, now this 5 amps and 2 ohms are in a parallel, and 5 amps and 6 ohm are in parallel. Now you can apply the current to voltage transformation. Okay, so I have applied source transformation, and I have converted this 5 amps and 2 ohms into an equivalent voltage source. Okay, an equivalent voltage source, that is, we know that I is equal to V by R. V is equal to I into R. So I is equal to 5 into 2, it is 10 volts. Okay, so 10 volts, and the equivalent resistance 2 ohm you are connecting in series. Similarly, the other branch, that is 5 amps and 6 ohm. So V is equal to I into R. 6 5 is a 30 volts. Okay, and retain the direction where the current is traveling, and 30 volts and 6 ohms. Okay, so now these 6 ohms and 3 ohm are in series. Okay, 9 plus 6 is 15, and this 2 ohm and 8 ohm are in series. 8 plus 2 is 10 ohms. Okay, so now we should convert this 30 volts 15 ohms voltage source into current source. So I is equal to V by R. 30 by 15 is 2 amps, and the positive polarity, so that current will move from left to right. Okay, 2 amps, and connect the same 15 ohms in parallel. And this 10 volts, so I is equal to V by R. 10 by 10 it is 1 amps, and the current, the positive polarity is towards the left, so the current will be traveling from right to left as indicated, and connect the 10 ohm in parallel. So after taking the equivalent resistance here, 3 ohm, 15 ohm and 10 ohm are connected in parallel. So the equivalent resistance is 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3, that is 1 by 3 plus 1 by 15 and 1 by 10. And after taking the reciprocal, we have got the value 2 ohms. Okay, we have got the value 2 ohms, and 2 ohms is 2 amps current, it is moving towards the right, and 1 amps it is moving towards the left. So dominant current source is 2 amps, so 2 minus 1 is 1 amp, and I'll retain the direction of 2 amps as it is a dominant current source. So it is current is traveling from left to right. Okay, so 1 amps in 2 ohms which are in parallel. Now you can convert it into equivalent voltage source. V is equal to I into R, that is 2 into 2, 2 into 1 is 2 volts. Okay, and 2 ohms. So this is what we are able to convert. We are able to apply the concept of source shifting. So in the beginning, there was no int where we can apply the uh, transformation directly. So only we applied shifting, current source shifting, and then we applied the transformation, and then we were able to reduce the entire circuit into a single voltage source and single resistance between the terminals A and B. Okay, so thank you. In my next lecture, I'll be explaining about the star to delta and delta to star conversion, and we'll see the problems based on that. Thank you.